Exercise 1.3, question number 1. Write the following in decimal form and say what kind of decimal expansion each has. So starting with first part, that is 36 by 100. So we'll solve for 36 divided by 100. Thirty-six 0.100 into 3 is equal to 300. 60 100 into 6 is equal to 600. So as we can see, we are getting remainder 0 and quotient as 0.36. So the decimal expansion of 36 by 100 is 0.36, and since the decimal expansion and after finite number of steps like this, we can say that the decimal expansion is terminating. Next is part 2, that is 1 by 11. So we will solve for 1 divided by 11. Zero, zero, 0, 11 nines are 99, 1, again we'll put 1 0, again is smaller than 11, so we'll put 1 0 more. 11 nines are 99. So here we can see that 09 is repeating. So the quotient is 0.0909 and so on, and remainder is 1. So we can say that the decimal expansion of 1 by 11 is 0.0909 and so on. And since 09 is repeating, we can also write it as 0.09 bar. And this decimal expansion doesn't terminate, so we will say that the decimal expansion is non-terminating. Next is part 3rd. That is 4 1 by 8, which is equal to 33 by 8. So we will solve for 33 by 8. 8 fours are 32. 1. Since 1 is smaller than 8, we'll put point and 0 here. 8 ones are 8. 8 ones are is smaller than 8, 0. 8 into 2, 16. Remainder 4. Again we'll put 0 here. 8 5s are 40, which gives remainder 0. So from here we can say that quotient is 4.125 and remainder is 0. So the decimal expansion of 4 1 by 8 or 33 by 8 is 4.125, and since the decimal expansion terminates, we can call this decimal expansion as terminating. Next is part 4, that is 3 by 13. So let's solve for 3 by 13. 0.13 into 2, 26. 4. 13 into 3, 39. 1, 0. Again less than 13. So we'll put it 0 here and 0 here. 13 into 7, 91. Gives remainder 9. We'll put 0. 90. 13 into 6 gives 78. Remainder 12. We'll put 0 again. 13 into 9, 117, which gives remainder 3. So here we can see that the block of digits 0.230769 will repeat from here. So we can say that the decimal expansion of 3 by 13 is 0.230769 bar, and since the decimal expansion doesn't end after the finite number of steps, we can say that it is a non-terminating decimal expansion. Next part, 2 by 11. So let's solve for 2 by 11. Since 2 is less than 11, put 0 here. 11 into 1, 11, gives remainder 9. We'll put 0. 11 into 8, 88, gives remainder 2. So here we can see that the digit is repeating again. So we can say that the decimal expansion of 2 by 11 is 0.18 bar, and since the decimal expansion is repeating again and again, so it's a non-terminating decimal expansion. Last part, 6th, 329 by 400. 329 is less than 400, so we put point. 400 into 8 is 3200, which gives remainder 90. We'll put 0 here again. 400 into 2 is 800, which gives 100 remainder. We'll put 0. 400 into 2, 800, which gives remainder 200. We'll put 0 here again. 400 into 5 is 2000, which gives remainder 0. So the decimal expansion of 329 by 400 is 0.8225, and since the decimal expansion terminates, this is terminating decimal expansion.